where we are more moving towards is more transactional, right? It's not just about consuming. It's not about question answering. It's all about also to be able to perform tasks. For example, you want to create an incident, right? You want to create a lead in Salesforce or anything like this, right? So that's what we have been more looking into, so that it's not purely a consumption layer, but it also becomes a transactional layer.
Hello and welcome to the Data Culture Podcast. I'm Carsten Bange, founder and CEO of Bark, and today with me is again Florian Bigelmaier, analyst at Bark. That means we have a special Data Festival edition again of this podcast, because our guest today has been a speaker at the last Data Festival online, and Harsha Gurulingappa is the head of AI and machine learning practice for Merck. Merck is a constant guest at the Data Festival, so it was great to invite him and hear more about his view. Florian, what did you talk about?
Hey, Carsten, I was super excited for this episode because for many customers and readers of our research, we hear that scaling AI is such a big topic these days. And Harsha is responsible to build like the technical foundation for Merck in terms of AI, delivering the right tools. But we did not dive just into like which technologies they have chosen to enable data scientists, experts, but also users. We also dived into the use cases. What are they building with it? How can you measure the success and the impact of all the things the many thousand users on that platform are generating? And in the end, we even looked into how that will turn out with Agentic AI and which kind of challenges companies have when scaling Agentic AI for systems that might have a little bit more risk than just doing retrieval augmented generation, for example, Q&A chatbots.
Absolutely, and scaling it is. Merck has 50,000 users on their platform. So let's dive in and hear.
So Harsha, great to have you. Let's start pretty simple. We want to talk today about like how you're scaling AI at Merck. What is like the organizational setup, and what do you want to achieve to maybe start easy and give a bit of context?
Sure, thank you. So first of all, thanks for having me here. So it's a pleasure to be here. So maybe I'll start with the organizational structure, like what's the operating model, how do we work? So I think that might help in contextualizing a bit to your question. So I work for Merck, and then, as you know, Merck is into three areas of business: life science, healthcare, and electronics. And we are a part of a central function, and we are called as Merck Data and AI Organization. And it's headed by a chief data and AI officer, Walid Mehana. And so what we do is we are a team who enable our sector colleagues so that they can use the technologies around data analytics and AI so that they can build successful use cases, right? That everything that falls in the surroundings of data analytics and AI. So that's typically an operating model. So what we do is that we offer the technologies. So we cover a complete spectrum of technologies when I speak about data analytics and AI. Everything that goes all the way from basic ingestion of the data, storing of the data securely, ensuring that the data is transformed systematically, data engineering, anything around data warehousing, business intelligence, analytics, and then that can go all the way towards craft technologies or technologies around AI, traditional AI like data science, more modern AI with respect to generative AI. Right? We try to ensure that we cover the end-to-end spectrum, that everything falls in the scope of data analytics and AI. And we offer the technologies, and then which is then used by our sector colleagues so that they can build the solutions or use cases that can create value or impact for the enterprise. So that's the core operating model, organizational model. And my scope of responsibility is around the AI topics. So I lead a practice for AI and machine learning. So anything that is related to more traditional AI, like data science kind of activities, or probably more the modern GenAI. Right now we speak about agents. So everything that falls in the scope is what falls in my responsibility to offer best practices, governance, platform technology tools, so that our use case teams within the company can use them to build right solutions, right, that can create an impact and the value for the business. So that's how we operate. So to your question, Florian, in terms of how, right, what is our strategy for the AI, right, as a for the whole organization? So again, focusing on AI, first of all, we try to differentiate between the traditional AI and let's say the Gen AI. So what we do is we, and also in the both communities, we still have two to three levels of maturity within the colleagues, right? So people who are kind of more new and who wants to learn and who wants to kind of do some basic day-to-day activities. And then there are probably some people who are more advanced and technical enough, and they can do more complex, sophisticated things. And what we do is, what we have within Merck is we have an enterprise AI companion. So its name is MyGPT. It's a more Merck internal name. And with MyGPT, what we do is we wanted to ensure that we offer a GenAI to everyone at Merck. So we now have been able to scale MyGPT to approximately like close to 50,000 employees at Merck, and with almost 30,000 plus being active users of MyGPT, which means they use regularly. So that's the scale that we have. And then they have like a front end. It's like an end user facing application where people can log in and you can do chat with large language models. You can build document chatbots, for instance, also build some simple flows, for instance. So that's what we have been currently offering, to, especially for the people who are new and then who wants to use AI for the day-to-day work, day-to-day productivity purposes. Then when you speak about more experts, right, people who can code, who can do some heavy lifting, and who wants to build highly customized solutions and highly customized capabilities, we offer them a toolkit. An internal name, we call it as an agent toolkit. So technically, it's a highly modular platform that offers the best-in-class technologies that people can use it to build agents. They can build still assistants, chatbots, but with a high level of control, for instance. Right? So in this way, what we do is we try to differentiate between more of our day-to-day users who wants to use AI for the day-to-day kind of automation task, a simple desktop automation kind of activities, and something where you have more experts like data scientists who can then build more complex, right, systems, complex maybe chat applications, maybe complex RAG kind of applications, but with higher level of control and higher level of accuracy, right? So that's how we look at things.
Super interesting. Immediately to minds comes the question of scaling. So you said 50,000 users of the internal application, the ChatGPT applications. So what challenges did you have to solve, both technically and organizationally, when you scale an AI system to such a large group of people?
Yeah, I think that's a good question. So we have been on this journey for probably, I think, close to 2 years, I would say. So as soon as ChatGPT was a big hype in the market, so I think we were one of the first in the European market to release something very similar, but that scales to a large enterprise. So our strategy has been to have a phased rollout. So we started with a first cohort of approximately 10,000 users. Then we scaled to the next larger cohort and so on, right? So that has been our strategy to roll out to a large audience like this. In terms of challenges, I would say that I would say two categories, right? Technical and let's say more of a non-technical ones. So the non-technical ones is we speak about things like governance. How do we ensure that people are using, let's say, MyGPT in a way which has to be used? We have a proper traceability of who is using this, for what purpose it is being used, what is the kind of value that people generate. So the first thing was, how do we ensure that when you release something like this to a very large audience, that there has to be some level of transparency, traceability, right, in terms of who is using it for what and so on. The second thing that definitely comes in is around data privacy, right? So we want to ensure that people don't use it for anything that is affecting the personal information of employees, right? So how do we ensure that we have some kind of a guardrails well defined so that we don't upload anything into the systems, right, that could hamper any personal related information of any employees at Merck, right? So it has to be sensitively used. So that's one thing. The next thing is around the security. I mean, that's an important one, right? Because eventually when people start using a system like this, eventually you start integrating your platform with other legacy systems, right? Maybe your Microsoft ecosystem, or may want to start integrating with any other data platforms, right? This means there is a data flow happening into the system, outside of the system, right? And then how do we ensure that it's secure and it's well tested, it's well documented, it's future proof. So these were three things, and the fourth one, not to forget, is the legality, right? Because when you want to use a system like any GenAI kind of systems, and then there could be regional restrictions, right? Like the way you use a system in US, the way you want to use it in Europe, for instance, if you want to kind of more roll it out into APAC kind of countries, right? There could be more regional regulations, right? So in terms of how to use the systems. So the way we started was, one is, as I told you, the phased rollout. But before even rolling out to employees, the first thing is to ensure that we have a proper data governance in place for traceability. We have a proper data privacy mechanisms in place so that we are able to ensure that people use the systems and we don't hurt any personal information of employees. Third one is the whole topics around how well we're able to integrate with any other systems. For instance, it's secure, right? It's well designed and it's future proof. And in terms of legal, any kind of legality that comes around, by ensuring that it can be used in a way which is also respecting any kind of policies that is respect to the specific regions of being used. So those were the four things that we had. And I think technically it's more about ensuring that the proc system is properly tested. We do a proper load testing, right? We simulate the test so that we're able to kind of have that load of, right, thousands of people using it. So that typically comes in proper documentation, proper best practices to design a system like this, to build a system like this, to scale and to operate. Right? So building is one thing, but how do you operate systematically, right? How are you able to now track any issues, track the feature request? So that's all kind of goes into the direction of how do you continuously improve the system once it goes live to a very large audience. So these were some of the things that we had to keep in mind before rolling out MyGPT to this large audience.
So the next obvious question after now listening to like how many people use the platform and how you build the guardrails and scaled it is, what are they actually doing with it? So do you have any kind of insight? What are like very common use cases? Where do you see like large impact for your organization as a total?
Yeah, in terms of the use cases, right? Again, it's an evolution, right? So the system has been existing, MyGPT has been existing since at least 18 plus months, and then it has been evolution. So as of today, I think a large number of use cases kind of revolve around to be able to find information from our Merck systems, right? So in traditional sense, we call it as a RAG, retrieval augmented generation has been the name, so that you have documents, files, data, right? Data could be present in structured databases, data could be present in graph kind of databases, unstructured databases, right? So it's like it's spread across. So the first challenge that we had, or let's say the first set of use cases who try to get value from MyGPT was that how are we going to really find the information accurately, right? From all these different systems of different nature. That is where I think the whole topic of agentic RAG becomes important, because when we speak about RAG, it's more about, right, you have your large language models, then you try to provide a context and you try to find the right answer, right? So that has been the traditional RAG approach. But where we see people more going towards is something called as an agentic RAG, where you have information not present in one system or one database. It could be multiple systems, different formats, sometimes files, mix of files and databases, and so on, right? And the agent should be smart enough to understand where it has to find the answer and then provide the right and accurate information back to the user. So that is the kind of evolution that we have seen. And then to your question, right, in terms of where you see a lot of usage, I think a lot of usage as of now is that to be able to use MyGPT and all the technologies that you offer around GenAI is to ensure that we're able to really find information from the complex, right, data that we have within the organization, right, which is spread across different landscape, different technologies. So that's the biggest thing. But where we are moving towards is more transactional, right? It's not just about consuming. It's not about question answering. It's all about also to be able to perform tasks. For example, you want to create an incident, right? You want to create lead in Salesforce or anything like this, right? So that's what we have been more looking into, so that it's not purely a consumption layer, but it also becomes a transactional layer where you can create records, right, to the original system of records as well. So that's where we are more moving towards. In terms of the value and impact that you asked for, I think that completely depends on application to application, right? We have users from research and development. We have users in manufacturing, for instance, commercials, post-market, right? We kind of see a fair distribution across. Maybe some successful stories I can provide you is we have colleagues in electronics. So what happens in electronics is we have a lot of lab records present in lab notebooks now. We have lab notebooks. It has a lot of information about lab experimentation that happens in the labs. It is a highly chemistry-oriented domain. I mean, you have chemical structures, experiments, reactions, right? I mean, it's something not that easy for a standard LLM to directly work with. So let's say they have built a system that can analyze those lab information, the lab records, and that can provide information to the scientists so that they can design the experiments, right, based on all these triple experiments. And the idea there is that we are able to minimize the cost. So the cost of experimental failure, right? So we want to be successful with experiments, and we want to minimize experimental failures. And that's one of the examples where we help the R&D scientists to be able to find information from the previous experiments, design better experiments, so that we increase the likelihood of experimental success, and we minimize the risk of experimental failures, especially the cost associated with it. So that is one example. The second example I can offer you is in the manufacturing domain. So in the manufacturing, we have a process where you have a manufacturing problem. It's called as a deviation. Then there is a next step is a root cause investigation, and next is a CAPA, corrective and preventive action. And this is like a standard process followed in all the enterprise, especially for the quality management systems. And then if you look at the manufacturing sites, then we have thousands of manufacturing deviations. Could be man-made errors, sometimes could be anything experimental, anything. It could be any machine failures, right, or anything like this. And usually what the difficulties for the colleagues on the site is to be able to scan all the historical issues, like all the problems or incidences, so that we are able to define better root cause investigations and better CAPAs, so that we are able to minimize the deviations, right? Ideal cases, we don't want the deviations to recur. So that's one of the examples where, like, MyGPT and the technologies around GenAI is then being used to ensure that we help the experts on the site to scan the historical deviations, right, and to identify strategies for better root cause investigations and better active and preventive actions. So in this way, we have, let's say, multiple across the complete function sectors and value chains, but probably these are the two examples. You can imagine typically how a system like this is being used.
You mentioned agents. I'd love to learn more about your agentic AI strategy, especially if you can share a little bit about the technology approach. But then also, again, the question, do you build like centrally agents that can be used across the enterprise, or is it a highly decentralized topic so people automate their processes in their domains? Could you share a bit around agentic AI?
Yeah, I think that topic of agentic AI is anyway evolving. Right? So we are trying to ensure that we equally evolve so that we can match the market standards. So that's what we have been doing. So when we look at agentic AI, we see this happen with 3 generations. The first generation of agentic AI is where the agents could perform simple single tasks. So we call them as tool calling agents. That's a traditional name used in the market, where you had an agent that could do a web search, call a tool for searching the internet, a tool to query the database, right? Anything like this. So it used to perform a very specific task. The second generation of an agent, we see it more as an hyper automation, kind of thing where you have multiple agents that comes together and they don't perform one task, but they can follow a complete process, right? So they can execute a complete workflow. And not necessarily that the agents are doing the things autonomously. So there can be some kind of an, say, the hardwiring happening, which means we define some rules saying how the agent should talk to other agents to perform the flow. So that's the second generation. The third generation is where there is a high level of agency or autonomousity. So that is where we speak about things like cloud code, right, for coding agents. Cloud co-work is one of the good examples. And then open claw, right? I mean, that also became pretty hot and viral in the market, where you could perform a lot of tasks. I would say could be yourself simple flows by using agents. So these are, let's say, highly autonomous agents, right? So if you look into our strategy at Merck, we have been quite successful in the level 1 and level 2. So we are right now at level 2, where agents has been used very much in terms of automating some of the workflows, right? So to have a workflow, and then you then have a selective agents that are being built, and agents to agents communications happens through a hardwired process, right? And it may not be necessarily fully autonomous, but nevertheless, you can run a flow, for instance, right? So that's where we are kind of right now. Of course, the third generation of agents is something that it's very interesting, where we see people using things like cloud code, and you can perform a lot of coding activities with agents, which has a high level of agency. But when it comes to the using such fully autonomous agents in the business processes, right? That is something, I think that's what we have been watching very closely, right? So there are opportunities, but I think it also comes with the risk, because we need to have a proper guardrails in place, right? You need to have a proper security mechanisms, right? So evaluations, I think there are a lot of things that one needs to look into. So for that reason, that is something that's on the horizon. We have been looking into it closely, so that how well we are able to offer such fully autonomous agentic systems to the end users. But right now, I think we are very much on this generation 2, say, of agentic systems.
Makes sense. I mean, like these three levels are really good to understand and to figure out, like from a high level perspective, where are we, where do we want to go? And I think they cover well a perspective that we're seeing in the market right now, that agents can take longer and longer tasks with more and more complexity. And the other thing I think is, which is discussed right now pretty much, is how fast do we get it from the frontier to the breadth of the economy? Like, I mean, you're in a very complex industry, I would say, with pharma and so on and chemicals. What would you say, like, how fast, or what are the biggest obstacles, let's put it like that, to operationalize all that frontier research and development we're seeing right now, and how long does it take to bring it to the production lines, to the people out there?
So I think that is where we very much look into the risk-based approach, right? So to have a proper governance in place, so governance is not about just traceability, it's also about ensuring that we are able to identify the risks as early as possible and able to flag, right? So if the application is low in risk, for instance, could be daily automation tasks, anything like this. So that's like level 1 risk, and then be it any function you work in, right? Be it R&D or manufacturing, post-market, doesn't really matter. But if these are low-risk applications, then the tendency of using the GenAI for production purposes is definitely higher. So it can be rolled out relatively quickly. But as the risk increases, which means you're using the GenAI for any processes that might have a direct impact on the quality, on the materials, the medicine, anything that we do, right? Clinical trials, anything like this. So that's where certainly it becomes slow, right? So that's where we need to really think through quite well. So for that reason, again, at Merck, we have different teams who have been working on, let's say, the whole validation topics around the whole AI systems. That includes in agentic systems. So that would very much take a risk-based approach, right? It always starts with what's the risk of rolling this over. If the risk is high, like if you are having a direct impact on, as I told you, right, on the products, the materials, on human clinical trials, anything like this, then eventually then we are trying to now work on a process, for instance, where we ensure that the systems can be properly qualified on the infrastructure level, it can be properly validated on the process level, and eventually it can systematically roll out. And as I told you, this is a work in progress. So the quality for the AI systems, AI processes is something that's a work in progress. And we already see that there are few low risk use cases that already has been rolled out, although it works in the vicinity of the manufacturing, the vicinity of clinical trials and so on, but it's a low risk. Because either it's a human in the loop involved or there's a very strong human decision that's typically being made before you take any business action, for instance. But certainly there are some use cases where there might be a need for higher level of validations, for instance, right? And that's where we are trying to work on a framework so that the framework can eventually be then used to ensure that we are able to systematically screen the use cases, screen the risks, and that we are able to now apply GenAI also to the higher risk category of use cases too.
You talked about agentic AI and that things move pretty fast these days. How do you pick and choose the right technologies? I mean, there are a lot of technologies from Python frameworks up to, like you mentioned, MyGPT, and as far as I know, you use a commercial product for that. How do you pick and choose those technologies?
Yeah, so if it's, again, as I told you, that probably one separation is it very much for a developer community or for non-developers, right? So that's the first distinction that we try to make. And if it's anything for developers, then eventually the easiest choice is anything that is highly modular, highly customizable. And our strategy is very much ensure that we don't bind or block into one big platform. And then we ensure that the developers have a choice. And as soon as the technology evolves in the market, we have an options to bring the relevant, let's say, tool to our users, so that we can scale, right, as the market scales and as the demand scales as well. So that has been our strategy. So when it comes to the developer community, I think everything around Python, most of the Python libraries in the market. So that's definitely one go-to, and that's what I think many people use within Merck. And then if you look at the whole technology landscape of AI or even the agentic AI, right? So there are a few 6 to 7 components that are very much concept, I would say. You need to have a memory, for instance. You need to have a vector database, for instance, where you want to offer some context to the systems. You probably need guardrails so that the agentic systems are not behaving or it's behaving in the boundaries. You need to have evaluations, then you need to have observability, right? So that you know what's happening behind the scenes. So this 6 to 7 are, let's say, the main technology components that you would need that you would get for a good agentic platform. And what we do is what we try to ensure that we look at the technologies in the market that are typically open source or semi-open source, like open source with some kind of an enterprise support, for instance, right? Because in this way, what happens is we get a visibility in terms of how the same technology is being used across the market. How are other companies using the same product? How is the academic community using the product, right? So we get a lot of visibility into it. So that's typically our favorite choice, is that our strategy is very much preferably anything that is more open source with enterprise offering, right? Second thing that we typically look into is some of the cloud offerings too, since we also work with some of the hyperscalers, and we also look into some of the cloud offerings offered by some of the cloud providers like Amazon, AWS, or even Azure. And then usually the last preference is something that's blocking us hard into one big platform. I mean, that's the least choice that typically we tend to make. So from a developer point of view, again, right, the first choice is always open source with enterprise offerings and very much hyperscaler based offerings. And then what we do is that we tend to then build an orchestration layer where the user or the developer is able to use these components and they can build highly customized, right? So flows or agentic systems or anything that they're working on. Could be even classical LLM applications too. Then for the first thing that you mentioned, Florian, that's especially for the non-developer community, right, for the consumers. So that is where we collaborated with a Berlin-based startup. It's called as a Langdoc, and of course, we have some communications already available on this on LinkedIn and so. So that's again one of the one of the platforms that has a very rich user features where people can build simple chatbot applications, right? They can upload files and they can build automate chatbots. Now they are also getting into workflow kind of functionalities too. And that is, again, as I told you, very much UI, very front-end driven and more targeted for non-technical people to be able to build simple flows, build simple chatbots in a much more intuitive and user-friendly way. So that's how our technology looks like, more for developers, which is more open source driven, and something for the non-developers, one platform, but very much user-friendly, and which also scales as the technology scales in the market as well.
Harsha, you are global head of AI and machine learning. And I wonder whether all these Gen AI investments you also described are now more or less monopolizing budgets and attention. I want to know what happened to machine learning. Is that still something where you invest a lot, or is it something that has been established and is now stable? Just your take on that discussion.
Yeah, I think that's a very good point. I mean, if you look at Merck, there are few use cases. They still train models, but highly customized models. Maybe a couple of examples I can offer you is we have a Bayesian optimization. The product is called as a Baby, and it's available on the GitHub. And some of the colleagues who worked on this within Merck decided to give it to the open source community so that the community can pick this up and they can mature. So that is one of the examples where it's not GenAI necessarily, but it's still the traditional AI, very much focused on optimization problem, right? Where you really fine-tune the models like from scratch, for instance. The second example I can offer you is like one of the use cases where some of my colleagues have been working on computer vision problems, especially looking at the microscopic images. Like you look at microscopic images, you then try to denoise the image, and then you try to find some particles, right, objects present in this image. And that's one example where they try to use all the latest and greatest large language models, vision models, and that did not work because this is highly domain-specific data. And the definition of what object you want to find within this microscopic images, right? So only the expert knows, and that needs to be taught to the system, right? So that cannot be easily be done through an LLM. So these are two use cases. Of course, we do have multiple of them like this within Merck, where people then train highly customized models, be it more predictive models or be it more computer vision models and so on, where you try to now take a specific data set, specific problems, and then try to ensure that you're able to build or even train or even fine-tune models to the specific use cases, right? So that typically happens. But to your point, Carsten, it is not excluding the whole GenAI, right? So people might still use LLMs for getting code examples. So they may want to use it for code completions, maybe for code documentation, or to get some inspirations, like to get some ideas. So GenAI is still involved in the data science, but not necessarily to replace anything, but rather to augment new ideas, to be faster at coding, documentation, creating test scripts, creating test plans, anything like this.
Harsha, thanks so far for this fascinating discussion. We come to the end of our time, but maybe to finish it off, could you sum it up? What are the success factors for scaling AI in such a large organization?
Yeah, so I think one is I think we should be able to measure the adoption. So adoption is one thing. The second one is more around like the ROI or the value and the impact. So when we look at the value and the impact, we look at it from multiple directions, multiple ways, you can say. One is it's around productivity, right? How much time is being saved, for instance. That's one metric. The second metric can be the revenue, for instance, right? Is the usage helping us in getting the revenue? The third one can be customer satisfaction, for instance. When you roll out our products to the users and their customers, how happy they are, right? So that also goes in the direction of adherence and churn, that we're able to retain the customers and we can minimize the churn as well. So these are, let's say, the three things that comes to my mind. Of course, the last one is most important, is the compliance with the risk, right? We want to use AI in such a way that you're able to minimize the risks and we can maximize the compliance. So when there is any audits happening, anything like this happening, We want to ensure that we minimize the gaps, we minimize observation so that our systems and processes are compliant, right? So those are the 4 ways how we measure, 4 plus, I'm just giving 4 as an example. So there are definitely 4 plus ways of how we can measure the value and the impact. And that is how we see is that I think any system that we introduce, we want to ensure that we're able to see, right, the 4 plus dimension that I mentioned, that we're able to get the benefit of the 4 of them, right? So that's one thing. And then certainly what we want to see is that we want to see the compounding effect, right? It's not that we have a successful few use cases and it eventually it's kind of stabilizes down, but there has to be compounding happening. And that is what we measure over the period of time, is that how well we are able to compound those effects from the 4 metrics that I mentioned about, and then how much benefit we're able to see at the end of the year or in the end of a quarter, for instance, right? When you compare to what has been invested in the beginning. So I think in this way, we ensure that, right, we are able to measure the success, we're able to see the compounding effect for the period of time, and then we're able to prove to the business saying that whatever we invested into is paying off, right, in 4 of those 4 dimensions.
Excellent. Thanks so much for sharing all your experiences and basically the ongoing rollout of AI in the organization. It's great to also have you at the Data Festival. You spoke at the Data Festival online in October, and hopefully we'll see you again at our next events. With that, I say thanks a lot and all the best to you. See you soon. Bye-bye.
Thank you. Thanks for having me.
Thank you.